Whakatakatahau ki te uru, whakatakatahau ki te toka. Kia mā kina ki uta, kia mā taratara ki tai. E hi ake ane tā te kura, e tio, e huka, e hauhu, ti hei mauriora. Koutou e noho nei mua o a hau, kua tai mai nei i tēnei pō tino makariri. Tēnā koutou katoa. Tēnā koutou katoa tō whakanui o te kaupapa o te wā, te mahi o hanga whare i te ao katoa. Rātou kua wehe ki te pō, haere atu rā. Tātou o te kānohi ora, tēnā koutou katoa. Kia ora, ladies and gentlemen. My name is Joseph Cullen. My phone is not loaded with anything. It's just a timer to let me know when I go overtime. Jessica asked me to speak to you about building and its effect on the environment and a mana whenua perspective in these times of climate change. I come from Ngaituahuriri, which is just up the road. I have a history of kaitiakitanga within Christchurch, and that's an ethic that is embedded in me. It's one of sustainability, and my first key word to you, or my first key waha to you, is mō tātou, mō ka uri, muri, ke nei. Not just for me, but the people who come after me. Children, grandchildren, great-grandchildren. Sustainability ethic is also honed by the fact that Māori mother, a European father who was a blue-collar worker, we come from a lower socio-economic group at the time. And so we were challenged with making things last and stretching things and augmenting them. A lot of that comes from my mum. Her ancestors, that was also familiar to them. You get that when you spend 10,000 years sailing around the Pacific from island group to island group with a finite amount of resources at the start, not knowing when you're going to arrive at your next homeland to populate, overpopulate, deplete resources and make the choice to go sailing off into the sunset again. If you do what you have always done, you will get what you have always got. My ancestors arrived in this country perhaps 1,000, maybe 800 years ago, and went through their own case of climate change. Sudden drop in temperature. Through innovation, they survived and prospered. They used locally produced sustainable materials with low carbon miles. They built by orientating their buildings to catch the sunlight in the lower temperature range of the winter, facing north. They lined their whares with a locally produced natural resource for insulation. Conservation ethic and stewardship, kaitiakitanga, embedded in us. There's a question asked of me at a workshop I was at. Joseph, do you like bacon and eggs for breakfast? Yes, I do. What's your observation on the bacon and eggs? And I sort of pondered it for a while, and my friend saved me the pain and says, on your plate of bacon and eggs comes from a pig and a chicken. And I'm like, duh. And he said, the chicken's involved, the pig's committed. And so that's my point to you. How green are you? How committed are you? It's all very well to say, I'll design a greener house. It's all very well to say, I'll use appropriate methods, low carbon miles, but how actually committed are you to embed it not only in the buildings that you build, but your actual work space, work life? How committed are you that you not only take it to your work, but you live it at home? Te Rūnanga o Ngāi Tahu we have, Te Rūnanga o Ngāi Tahu is the hub the rich parents, if you will, of a family of 18 papatapurunanga who are scattered around the South Island, based at our Papatupu marae, each of them in different stages of their development, if you will, after settlement. We have a range of assets. Where I come from, as part of our settlement, we ended up with the Eelwell Forest and we turned it into a farm. With our cultural advisory group, we stayed embedded in the farm operation because those who would manage it aren't as hard green as us. They don't have it embedded in them, this kaitiakitanga ethos. I'm not saying that it's the answer to everybody's problem or to climate change, but the reality is that we have to get harder green. Mō tātou, a mō kauri a muri ake nei. Because what kind of legacy do we leave our children? What do we leave them to pick up in the future? We can manufacture locally produced sustainable materials with low carbon miles. COVID-19 and the supply chain issues that it has brought focuses the spotlight on the opportunity to bring manufacturing back to this country. Bounce the dollar around the economy instead of taking logs from a forest and accepting the highest price on offer and watch those logs sail off to China and then come back as even higher priced building components. Sometimes the answer's right in front of our eyes. In this case, I think the answer was right in front of our eyes 800 years ago, when my ancestors arrived here. Look around the environment, sustainably produced, low carbon miles, and innovate. And that will be something to leave your children and grandchildren. Kia ora.
Ki ngā maunga, ki ngā waka, ki ngā tātai tangata, nāia te reo o mihi kia koutou, tēnā koutou. E te pauwhakaruru hau o te takiwā nei, e nai tūhururi mi ngā runanga, tēnā koutou. Ko Sarah Templeton oku... Ko Sarah Templeton toku ingoa, no ingarani oku tūpuna, kei te noho o ki o te tahi. Tēnā koutou katoa, ngā mihi nui kia koutou. So I am Sarah and I currently chair the Committee of the Whole, so all of Council, which is the Sustainability and Community Resilience Committee, which has under its terms of reference the climate change strategy and other sustainability initiatives. Christchurch City Council has been working on climate smart initiatives for some years now, and in 2017 we set ourselves a target of becoming net neutral as an organisation by 2030. In 2018, we asked our council-owned companies to do the same, and we consulted with residents on a city-wide target. In late 2018, we resolved to set a target for the city of being net neutral by 2045 and to halve our CO2 emissions by 2030. This is a huge undertaking, and there is no way that council can do it alone. It will take central government, business, iwi, community groups and individuals all to play our part. As you'll be aware, transport makes up the greatest proportion of the city's emissions. Along with other projects, Council initiated the 100% battery electric car share scheme for the city. And we've also been working on our network of major cycle routes, which are well on the way to being completed. We've made some progress in the built realm, both in major facilities such as Tūranga and the recent opening of the St Albans Community Centre, almost entirely made of wood and with net carbon stored of 173 tonnes of CO2 equivalent. This year, for the first time, our long-term plan has a climate change lens. First time. It's a good first step, but it won't be enough, and the next LTP will have to step up significantly. Among other things, we added additional funding for community partnerships, for biodiversity, for tree planting, for climate change education and active travel planning for schools, for slow-speed neighbourhoods and coastal adaptation planning. We also added a new cycling program. You may not have heard of this. We added a new cycling program, $40 million for local connection routes. our new climate resilience strategy was signed off just a couple of weeks ago. It's called Kia Tūroa Te Ao, ensuring the world continues. It is a start, and there is so much more to do, and we all need to do it together. As the saying goes, we cannot make progress without change, and there is a lot of change that we need to make. Finally, I'd like to thank Dr. Jessica Halliday and the team at Te Pūtahi for this evening and this series of Christchurch Conversations on climate. The City Council is really pleased to be able to support it. Nō reira, tēnā koutou, tēnā koutou, tēnā koutou katoa.
Kia ora koutou, and thank you, Joseph, and thank you, Sarah, for setting the scene for us. I think in particular that whakatauki for our children, and well, not just for us, but also for those who come after us, is one that this whole city could think Ngāi Tahu for and carry through the journey that we've got ahead of us. Just a quick thank you to all our Expo contributors tonight. It's been great to have you here and great to see you so busy tonight. Housekeeping, that's right, that's what I've got to do. So, toilets, you know where they are, correct? They're out in the middle of the room on the right-hand side, just past the big screen. I hope you've all signed in with the QR code. If you haven't, we have a manual sign-up, or you could enter it manually when you get home if you keep forgetting your phone, like I have a lot lately. You know the drill for earthquake stop. Oh, well, no, just drop, cover and hold. The tūranga staff will lead us out. The exit is just on my left, your right, with the little green figure. Those are stairs that would take us down and out into Gloucester Street if we needed to evacuate, but you have to walk all the way around the building to the muster point, which is in the square. So, Christchurch Conversations towards 2030. We are really pleased to bring this series to you this year. This event series considers how we can meet the city's emission reduction goals that Sarah just outlined. The topics reflect somewhat the way the Christchurch City Council is measuring greenhouse gas emissions, but also reflect the way emissions are produced by the way we design and build and use our cities, because at Te Pūtahi, our concern is architecture and city making. We exist to make it easy, desirable and fun for anybody and everybody to get involved in the shaping and enjoyment of the city. Now, we acknowledge from the outset the complexity and interaction of the environmental, social and cultural challenges and changes that climate action requires of us, and also that these topics are not divisible. Building and construction is not separate from energy generation and use. Neither is transport separate from land use. So these things are all intermingled, the 5 topics that we'll look at this year, but we had to make them intelligible to us and to you. And as Sarah's outlined, and in fact as Joseph's outlined as well, addressing climate change and reducing emissions is now our collective goal. We've committed to this as the globe's committed to it through the Paris Agreement. We've committed to it as a nation and now as a city. And our first target is less than 9 years away. But I don't know if you've noticed, being here now, things are changing. And I think it's a great time to reflect and to thank all those groups and people who have been sharing this message for decades. This series and this event tonight are about sharing information, about how together we can reduce emissions in Ōtautahi Christchurch, and that everyone can contribute in some way to our collective action. Tonight's event in particular looks at how we design, construct, adapt and use our buildings. As with other areas of climate action, there are significant co-benefits in reducing emissions in our buildings, especially in creating better indoor environments for health and wellbeing. I'd like to thank the sponsors who have made this evening possible, this series possible, the Christchurch City Council, the It's Time, who are our Christchurch Conversations partner and have been since, well, we've been there since 2015. The It's Time Canterbury Climate Campaign, who are our series sponsor. Our research partner, which is the Huritanga thread of building better homes, towns and cities, one of the national science challenges. And tonight's event sponsors, the Building System Performance branch of the Ministry of Business, Innovation and Employment and the New Zealand Institute of Architects Canterbury branch. So how is tonight going to roll? Well, we have a really packed program, so our speakers are going to introduce themselves. But to give you an idea of the shape of the evening, I'll give you a really quick overview. At all of the series of 5 events this year, we hear from a young, or he says youngish, tonight, person whose life is going to be shaped by the action we take now in this next decade. So our next speaker is an architectural designer who will consider how he and his peers might practice architecture in 2030. We'll then hear about how and where emissions come from in building and construction. Other speakers will then take us into the detail of the more technical and regulatory aspects of change in the sector. You know, if you're not in the sector, hang on. And then a couple of people are going to look at how those could be implemented before we cycle back again to consider the wider context of a healthy urban system. So thank you to all of tonight's speakers, there are a lot of them, for sharing their knowledge and insights with us. And thank you all for coming. We hope that we all gain, and those who come after us, gain from learning more about building for the future. So please welcome our next speaker, Johnny Knopp.
Kia ora ana koutou. Johnny ko toku ingoa, Maoke o te Kukearani, toku motu. And we came via Takitumu, so just for fun. I'm an architectural designer and I'm here to talk about buildings, I suppose. First of all, I don't represent all young people, just so you know. It's a huge privilege to be here and it's a huge privilege to have my job and be able to influence how young people are represented and seen and heard. They should be heard and seen. So on to buildings and the environment. Basically, environmental damage is going to happen when we touch the ground in one way or another, and reducing that is a really worthy thing to put your efforts into. I'm not an expert in reducing that damage myself, so what I'm going to talk about, sorry Jess, is why we build what we build in the first place. Because the wrong building, no matter how well built, can't justify its own existence in terms of the damage that we have. So there are some times when the kind of cost-benefit analysis of environmental damage versus infrastructure don't really stack up. And in those times, maybe not building is the best thing to do. And other times, maybe going big is actually the way to do it. So, all right, how do we, with all the wisdom of a 32-year-old, design the right buildings? Great slides. Traditionally, the realm of these first few questions have been where the designer has had influence. So who's going into the building, when do you want it, last week. Where is your site? It's always a good question. And what are we building? All right, what are we building? What is it? Holiday home, it's a library. But why has usually been the domain of the developer. The one that's with the money, whoever that might be. Why are you building? Why? Like, what is this thing? So, all right, going back to how do we get to the right buildings, we ask a lot of people a lot of questions. And a lot of questions, Michael? And the more important that question is, or the more valuable the outcome's going to be, a question like, can you build me a house that looks like a fish? The answer is yes. Well done. Can you build me a house that I can afford to feed my family if I'm living in? That's going to be a much more valuable outcome for the people who are working on that. So, all right, so we've got the traditional realms here. What we always try to do, like I say, is really push into this why space. That's my last slide, by the way. It's a terrible one to end on, but we try to push ourselves into this why space in the practice that we're in. So 2030 is probably too late to start asking that. So we're asking it now. It's what I was doing today. It's what I'll be doing tomorrow. Why do we ask that? You ask any 2-year-old. Why? And why is the most powerful question you can possibly ask. You can deconstruct realities with the question of why. I'm going to speed run one real quick example because I feel like my watch just told me I'm out of time. Okay. Hypothetical example. Actually, no. Number one. All right, let's say a developer says, build me a three-story, 5-apartment, $1 million per apartment building in a public space. All right, great. Why? So we can house some people. Okay, why? So we can make some money. Okay, interesting. Is the 5-apartment, 3-story building the best way to do that if you're in a public space? What if we went 5 stories? All right, ground floor, hospital retail, next floor up, offices, maybe a mix of expensive and less expensive apartments. Now, yes, that's cost more carbon, more money, more investment, but the business case potentially more robust. One tenant moves out, then you've still got the rest of them in there, easier to replace, and the kind of carbon expenditure per capita for who that building is able to serve suddenly raises like crazy. You've gone from 5 households to 100 plus people from the public wandering in every day. Speed run, another quick example. So that's going big. All right, so that's starting to try and stack that carbon argument. Another quick example of a speed run. All right, developer says, build me a new architecture school. I was just going to say school. Okay, why? Well, so we can house our students. Okay, well, what is it? Well, it's a replacement for our existing architecture school. Okay, well, where is it? Well, it's in the same place as the existing architecture school. Okay, when do you want it? As soon as possible. All right, well, who's going to go into it? Well, our current students. All right, so you're housing your current students on a piece of land that you currently have and knocking down a building that you currently have to do it. Maybe the better carbon argument is don't build a building. And on that fantastically somber note, I will leave you all. Thank you very much.
Kia ora, my name's Dr. Kerry Mulligan. I'm a senior academic at the Department of Engineering and Architectural Studies at ARA, Institute of Canterbury, which we have multiple campuses around the city. Tonight, my role is to set the scene for this discussion about carbon in buildings in Christchurch. During the discourse tonight, we're going to hear from a range of people, but while they're each going to be addressing a specific topic, the underlying themes is to endeavour to understand our situation here in Christchurch, how we need to be thinking about carbon in buildings, so improving our carbon literacy, and presenting a path that we can choose to take that can make the significant impacts that are required. Over the evening, you might hear some terminology that may not yet be in our everyday language. So as I set the scene and tell you a little bit about what's happening in Christchurch, I thought it'd be useful to unpack some of the words and terminology that we hear around the place. For example, the total emissions from Christchurch in 1 year is currently 2.7 million tonnes of CO2 equivalent. And at the moment, our emissions are increasing year on year. We know that we need to be reducing emissions and that emissions are bad. But how much reduction do we need? There's much debate regarding how emissions should be distributed. However, one useful metric, you can go back, is the fair share. This refers to the amount of carbon per person if everyone in the world had an equal share in the emissions. While the fair share is a little bit more complex than a single number, for the purposes of tonight, and understanding where we need to be getting to, that number of fair share sits around 2 tonnes of carbon per person per year. And how do we stack up against that? Well, if you distribute the emissions from Christchurch per person per year, we are each responsible for 7.1 tonnes. Our emissions are rather bloated. That fact that our emissions are rather exorbitant can be overwhelming. And while it might be motivating for some, we need a realistic and collective approach to the problem. And the first step in doing that is getting some understanding about where these emissions are coming from. So this chart shows a breakdown of the emissions for Christchurch. We can see that behind transport, the emissions from building are the next biggest and account for 19%, or almost a fifth of our emissions. And a little bit more terminology that we're going to come across. The emissions from buildings are grouped into two areas, referred to as operational and embedded. The embodied emissions are those resulting from the physical fabric of buildings, the stuff. So emissions from producing the materials for the buildings. We're going to hear more about that later from Katie, Scott, and Andy. The operational emissions are from using the buildings, from such things as lighting, hot water, and heating. And we're going to hear more about that from Elrond and also the implications around all of that. So it's emerging that we need to understand where our emissions are coming from and what we can do to change. And I think what we're going to discover over tonight is that we have good knowledge and expertise in this area and what will make an impact in the built environment. And where we are coming unstuck is at the systemic level. It is our policies and our procedures that are leading us down. I think we'll leave here with a better understanding of the leverage points that we have to potentially enact a change. Thank you.
Thanks, Kerry. Kia ora koutou. Hi, everyone. So my name is Katie Simons. Thanks. So I'm going to talk about embodied carbon and increasing carbon literacy, which Kerry's neatly introduced for me. But I want to tell you about where I've come from, first of all. So there's a picture of me looking quite fresh-faced, straight out of university with a hard hat on. So that tells you I used to go to building sites. So I'm a structural engineer by background, which means that I design the parts of the building that hold buildings up. And the picture on the right there is the first building I ever designed. It's a psychiatric hospital in Stevenage, just off the A1 in the UK, if anyone's been there. But yeah, fresh out of university, I was, wanted to put what I'd learned at university to good use, designing buildings, but designing buildings for the future and reducing emissions. And I was really interested, quite heavily influenced by this guy called David Mackay, who wrote that book in the middle called Sustainable Energy Without the Hot Air. And the tagline of that book, the driver of it was, it's all about numbers, not adjectives. So he became a special advisor to the UK government as they were looking to decarbonise their energy system. And he said, we can't do this just talking about numbers. We can't talk about, wind turbines being green or solar being sustainable. It's not about that. It's about numbers. And that really resonated with me as an engineer because engineers like numbers. There are a few numbers in here, but as Jessica said, hang on. So that's where I've come from on this journey. So looking at, as we've heard, emissions from a building, this is a picture of how we like to think about when we talk about emissions from a building, where do they come from? So we've got a whole life cycle diagram here. This is a lot of pictures up there, but essentially we're saying that at every stage of the life of a building and the life of the products and materials that go into a building, there are emissions. So those A numbers, that's making the stuff, the fabric of the building. Then the A is getting it to your building site. Then there's assembling it on site. Then we start using the building, and not only do we have some operational emissions from heating and cooling our building, but we also might replace stuff in the building while we use it as well. So they're all maintenance and repair emissions associated with that as well. Then we decide the building's no good to us anymore, we demolish it, we might chuck the stuff out, or we might try and recycle it. That would be a better thing to do. But all of those life cycle stages have emissions associated with them, and the embodied emissions are everything in that blue cloud. The operational emissions are the green ones left out of it. And the thing about the embodied emissions is they're kind of hidden and they're indirect, and that's historically why they've been hard to measure. They're harder to measure, they're hard to see than the operational emissions, which essentially come from your power bills. So that's looking at emissions from the building sector on a building perspective. But what about for New Zealand Inc. per year? A few more numbers here. So what did we hit? 2.7 megatons for Christchurch. So for the whole of New Zealand, our annual emissions are 69 megatons. And our modelling, we've come up with a number of 15% of that 69 megatons comes from the use of buildings in New Zealand. And that's broken down into embodied and operational emissions. There we go. So the operational emissions are the lower two. The dark blue is burning fossil fuels in the building. The kind of lighter dark blue with the arrow in it, that's electricity that we use to operate our buildings. But those top three bands, that's all your embodied emissions. The stuff from the material in buildings, the stuff from waste in buildings, and the pink one is important. It's the stuff from material that is made overseas and is imported into New Zealand. But that's still counted as emissions from the building sector, emissions that we drive every time we build a new building. So what's the government doing about this? So we're all hopefully aware of the Climate Change Commission. They published their final advice on how we are going to meet our zero carbon by 2050 goal a couple of weeks ago. That's going to result in the government responding by publishing a national emissions reduction plan by the end of the year. So the government has to do this. That's what the Zero Carbon Act passed in 2019 said we would have to do. And for the building and construction sector, we've responded by launching the Building for Climate Change programme, which is the programme that I'm involved with in MB. So last year we published these two frameworks for public consultation. They contain proposals to regulate the operational emissions from buildings and the whole of life embodied carbon emissions from building. And that's what I'm talking about now. Elrond will talk about the operational one later. So whole of life embodied carbon emissions reduction, bit of a mouthful. I like to call it WOLEC. So the headline of the framework that was published was we're going to start with new buildings. So every time you build a new building, you have to tell us what the embodied carbon of that new building is. Next step after that is, once we're all used to doing that, we're going to introduce a cap on embodied carbon. So you won't get a building consent until you can show that your embodied carbon of the building is underneath a cap. And then over time, we'll gradually reduce that cap in line with our national emissions reductions targets. So, and in the framework, we set out objectives of how we were going to do this, how we're going to measure embodied carbon and reduce embodied carbon. And I tried to keep it quite simple. So it is an equation there, I know, but it's essentially just multiplying three numbers together. It's the amount of stuff we build, that's the metre squared stuff. It's the amount of material we use to build that area, that's our material efficiency. And then it's the amount of carbon associated with that material that we use. So in essence, everything that we do to achieve the objective of reducing whole of life embodied carbon we should be able to link it back to reducing one of those three numbers. And I want you to think about those three numbers. Yeah, reduce those three numbers. So how do we do that? I'm really glad we've already heard about the term carbon literacy. So requires a bit of number crunching and does require us to be more familiar with the numbers and the magnitude of the impact and what a kilogram of carbon means. So it's really important that it's not just for specialists, but for everyone involved in the building sector. If we're going to do this, we need to do it together. We need to know what our impact is. It can't be something that we can package up into a black box and ask someone else to deal with. So we all need to have a kind of gut feel of what a good embodied carbon result for a building is over the whole of life. Because if we want to reduce that number, we're going to have to quantify it. We can't reduce something if we don't know where we're starting from. But the good news is that there is growing interest in this. Popular science books tells you, how much carbon is in your banana, becoming more and more popular. There's a growing interest in doing this. And what we want to try and do is empower people to give them the tools that they need to do this. So now I'm going to go back and do a quick example of carbon literacy and go back to the building that I designed, remember? So this is about quantifying my impact. So that was a steel frame building. You can see all those beams and columns made out of nice structural steel. There were 310 tons of steel in that building. And it was quite a big building. It came out to about 45 kilograms of steel per square metre of area in that building. Now, about that time, we would benchmark a steel frame building at about 75 kilograms of steel per square metre area. So for various reasons, I was able to design that building quite efficiently. And over the whole of that building, I saved about 200 tonnes of steel. 200 tonnes of steel compared with if it had been a kind of typical benchmark quantities. And going at about 2 kilograms of carbon per kilogram of steel, that's about 400 tonnes of carbon saved. So that's going back to those three numbers, that's that middle number, that material efficiency. So by able to reduce that material efficiency number, I've saved some carbon and I'm able to quantify it. But what does it mean? So I could compare it to a couple of things. I could compare it to switching to a vegan diet, which is worth about 2 tonnes per year per person. So it's about 200 years or 200 people going vegan for a year. Or flying back to the UK to see my family, I could do that about 100 times for what I did on that building. And that's not to say that we shouldn't all be switching to vegan diets and reducing our flights. I think what I'm just trying to illustrate is that my role as a graduate engineer straight out of university, I had the power, and it's a real privilege, I had the opportunity to make that change and to have that impact in my day job. And that's the sort of thing that everyone in the building sector needs to grasp hold of and understand and take those opportunities. It's not a new thing. I like to use this example as what I'd like to think of as an early example of carbon literacy. Back in 1978, that's Norman Foster on the left. You can tell he's an architect because he's wearing a black polo neck. The guy on the right is Richard Buckminster Fuller. He was also an architect, but was a kind of visionary, sort of polymath and a real early sustainability pioneer, kind of before it was fashionable. He was really, he became famous for designing these like super ultralight geodesic dome structures. And he met Norman Foster at a grand opening of one of his new buildings in the UK, and everyone was talking about how wonderful the design philosophy was and his inspiration. And all Buckminster Fuller wanted to know was, yes, Mr. Fuller, that's all great, but how much does your building weigh? And Norman Foster didn't know the answer. And I'd like to think that 50 years later, not only do we all need to know how much our building weighs, the material efficiency, but we also need to know what the carbon associated with our building is. So to conclude, so to reduce embodied carbon, increase our carbon literacy, it's about numbers, not adjectives. The real number that matters is that kilograms of CO2. We can't reduce things if we don't quantify it. So everybody who's involved in any way of buildings, know what your building weighs. And then know your own potential impact in whatever role. I've explained my role as a structural engineer, but there'll be all sorts of different opportunities for different people in the building sector to reduce their impact. So think about how you can reduce those three numbers. Thank you.
So, my name is Scott Watson, and for those of you concerned, I'm not on day release from the prison. It's a different Scott Watson up here today. And I'm Business Development Director, according to that, for Naylor Love. So I'm one of those evil builders that builds these carbon-eating buildings all over the place. A little bit of background. I'll just find the right button here. So Naylor Love, a few years ago, decided to measure its own carbon footprint, like a lot of you would have done, and we discovered that having 300 Ford Ranger utes wasn't a great idea, and a lot of the waste off the construction sites, etc. So we did our best to reduce those figures, and we're doing really well. But we also wanted to know what the best bang for your buck would be in terms of actually making a massive difference. We won't go back through the whole carbon cycle because we've been with other speakers, but the bit that's important here is engineered timber. We all know it sequences carbon as it grows. We know that it takes very little energy to produce compared to concrete and steel. And we know that as long as we plant another tree, the cycle continues. So if we chop down the Amazon forest and we don't plant any more trees, we shouldn't be building out of timber. So the sequence works as long as you continue to build out of timber. What sort of stuff can we build with timber? Pretty cool building. That's the Nelson Airport. Full seismic load taken by the timber with these expensive little brackets here. The more simple structure, I think there's Rangiora High School, Redcliffs Primary School. This is a hybrid building, so this building you can see the concrete structure in the middle. What the concrete structure does is takes the seismic load, and the rest of the building is timber, and that takes the gravity load. And through the studies we've done, we've basically come up with that as being the most economic commercial structure to build. Industrial buildings, this is a fertiliser works. We didn't build this to save the planet, we built it so it wouldn't rust. We got some brownie points. And the Cardboard Cathedral, which is actually a timber hybrid building. So inside every cardboard tube is a timber beam. Sort of like shooting Santa Claus, isn't it? Sorry about that. It's not cardboard at all. What carbon savings can we achieve with engineered timber? So we set about and we started to measure these. We took a sample building which you've probably walked past, Bedford Apartments. Now these are just down the road. They're a standard, modest sort of 4 or 5 story building, quite correctly built out of concrete and steel. We then redesigned it in 2 different ways. So we did a timber version, which is almost all timber, but still had concrete and steel foundations. And we did a hybrid structure on the right, which is timber and steel hybrid. Okay. We then created our own carbon calculator, which is basically the equations that we've been dealing with before, but we created a database of all the materials. So very briefly, when you measure these materials, there's the 3 different designs and the 3 different amounts of material. We saw that in the 2 to the right, we still have a lot of concrete and steel. So we thought the carbon saving would be fairly nominal. Anyway, we carried on and the saving was over 90%. So even with a real modest amount of timber put into the building, you can see on the far right, sorry, left, no, you're right. The difference between the hybrid structure and the almost total timber structure is quite small, but the difference in cost is significant. So for that particular building, the cost to build the hybrid, which on the right is on the far right, is comparative to the concrete and steel. It's a little bit more expensive, but comparative. If we went to almost 100% timber, the cost goes quite high. But, you know, it shows with the hybrid structure you can achieve a significant saving. Trying to do a comparator to that, for that one rather modest building, we were saving the equivalent of burning 1.167 million kilos of coal. So while it's great to do our hybrid cars and electric cars and waste control, etc., we do have to realise that just a nominal change to some of the building materials make a massive effect on the environment. It was at this point in time I had a Jacinda moment, which is not like me and actually quite disturbing. Come on, Jacinda, don't let me down. Okay, so that saving that we made was the same as 100 people, which is probably what we've got on here, driving electric vehicles for 8 years. That's a lot of electric vehicles and a lot of people. All that saving was just done by one building, changing some of the materials to timber. And for those of you that are interested, on the Naylor Love website, you can find our own carbon calculator, which we've released to the planet, and you can download that for free. And you can add and subtract EPDs from that with your calculations. 5 minutes, that was okay. Thank you.
Okay, good evening. You're doing well out there. This procession of speakers is carrying on, but we're doing well. My name's Andy Buchanan. I'm a structural engineer. I was, for a few years, Professor of Civil Engineering at the university, where I taught people how to design timber buildings and how to do a few carbon calculations on the side. So, am I doing the slides? I guess I am. No, nothing's happening. Here we go. So, what have I got here? Trees. This is the forest I own up in Marlborough. And what's in those trees? About half of the weight of the wood in those trees is carbon. There's carbon in those trees, and that's why people plant forests to sequester carbon. And you can do lots of things with carbon in trees because it can be stored in the wood. And if you build a building like this, you know that building? Old government building in Wellington. It's been there since 1876. I haven't got the numbers on that, but there are tons and hundreds of tons of carbon stored in that building, and that carbon is in the building. It's not in the atmosphere. If we want to encourage this, what I like to think about is something called a wood first policy. And there's a little bit of history here, because way back in about 15 years ago, when Jim Anderton was Minister of Forests and Deputy Prime Minister, he set up a wood first policy in New Zealand. Most people don't know about it. British Columbia followed New Zealand and set up a wood first policy. The state of Tasmania did the same thing. The city of Rotorua has done the same thing. What about Christchurch? Well, all of those previous places are timber towns, forestry. I think in Christchurch we should have a zero embodied carbon policy. What does that mean? It means if we decided for all of our new buildings that the carbon sequestered in the wood offsets the CO2 emissions from making all the other materials in the building, that would be zero embodied carbon. It would just be what you'd seen from Scott and from Katie. And as an example, let's look at the St Albans Community Centre. And that's the same building that's shown on the brochure here. I was at that building at the official opening about 3 weeks ago, and our Mayor, Leanne Dalzell, opened the building, and I asked her afterwards, why didn't you say something about the carbon? Well, we heard about it tonight. Sarah told us about the carbon in that building, because that's how the building was built. It's all built out of wood. There's no concrete in that building. It's got wooden panels for the floor and for the walls and for the roof. It's made of something called cross-laminated timber, and it's for the walls and the floors. There's about 150 tonnes of wood in that building, which is equivalent to 180 tonnes of carbon sequestered, the numbers we talked about. And the simple number I like to think about, I did a quick calculation. If you drove your car for 1 million kilometres, this would offset the driving of your car for 1 million kilometres. It's a huge amount of carbon, but one's not enough. It's even better than zero embodied carbon. It's carbon negative. So then I'd quickly say there are lots of other reasons for building in wood, and I'm going to go quickly now. The low carbon footprint, that's a renewable resource, lovely appearance, healthy environment, time and cost, lightweight structure, earthquake resilience, top quality performance. There's lots of other reasons for building in wood, not just the carbon footprint. But it's not so easy because there's a lot of resistance. And how do you get more timber buildings? Well, you lead by example, as Christchurch City has done with Mount Pleasant Community Centre, St Albans Community Centre and others. And then we have to support the public demand and encourage the building owners and celebrate the successful projects with some education for designers and builders, and promote the carbon benefits and promote the concept of zero embodied carbon. And here's another building on the right, the Young Hunter building down next to Vic's Cafe, Victoria Street. That is all a structural timber building with zero embodied carbon. So my conclusion simply is this: the more trees we plant and replant and use for timber buildings, the better it is for people and the planet. Thank you.
Kia ora tātou. I hope you can hear me now. Sorry, it's technology with these things, always a challenge. So my name's Elron Burrell, and I'm going to talk today about the operational efficiency part of the Building for Climate Change. I'm the Principal Advisor for Architecture and Design in the Building Systems Performance branch of MB, and I'm also an architect. I work part-time for MB and part-time run my own business as an architect, focused on low-carbon architecture, and I'm also Chair of the Board for the Passive House Institute New Zealand. The operational efficiency part of Building for Climate Change has three main objectives to it. One is to reduce the operational emissions, which Katie's already touched on in the whole of life carbon cycle, and that includes the thermal performance of buildings, the use of electricity and other fuels for building services and for other things we use in our buildings, as well as the water use. The second objective is about reducing water use in buildings, and then the third objective is to improve occupant health and well-being, which is related to the other two. So the first thing I think is worth mentioning is, why do we need to think about operational efficiency in New Zealand's context? We're used to thinking of New Zealand having a really high degree of renewable electricity particularly, There's a few different aspects to this. First off is that renewable energy does not equal emissions-free energy. So the electricity grid in New Zealand is partially powered by different forms of renewable energy, from hydro, from wind, from solar, etc. It also has quite a component of geothermal electricity generation, which has emissions associated with it. And then we also use fossil fuels, particularly this year, quite a bit, particularly when we have low hydro lakes and we're not able to produce so much electricity from those. And then alongside those also, the electricity grid has whole of life emissions. So Katie talked about the whole of life emissions from buildings, but the generation facilities and the infrastructure associated with electricity also have the whole of life emissions. So building more wind turbines, building more dams, those sort of things all have emissions associated with them. The other thing which is really important is that operational emissions accumulate over time. So when we build a building this year, we lock in its performance for a very long time to come. So the emissions that come out of it one day or 1 week or 1 year might not be so much, but over time they add up to a considerable amount. And the other thing is that, of course, we're trying to get New Zealand to zero carbon emissions by 2050. And that means we have to decarbonise a whole lot of other industries and a whole lot of other aspects of our economy besides just buildings and transport we talked about already. And one of the implications of that is that there's a whole lot of other parts of our lives and our economy that need to electrify and use electricity instead of fossil fuels, particularly transport. And so Transpower has predicted that on their calculations, we need to double capacity of electricity by 2050 to meet all those needs we're developing as we decarbonise. And so we need to look at where we can bring in efficiency. So we need to use less electricity to make that available for other aspects. And then, as I talked about, of course, as we build more and more, there's the life cycle emissions from that building out infrastructure we're doing also. And just to put some numbers to it, I think it's been a bit of a theme for tonight is to talk about numbers, not just general kind of things. Is that if, for instance, you had a 200 square metre house, it might be using somewhere between 20 and 30,000 kilowatts of electricity per year to keep it warm and dry and comfortable. If we take the current emissions factor from the electricity grid of 0.11 kilograms of CO2 for every kilowatt hour of electricity used, that means that 200 square metre house is putting out about 3.3 tonnes of carbon dioxide emissions per year. So that's in the context of, you think about the Christchurch number was 2.7 megatons per year. So 3.3 tonnes for one building. And so what we're looking at with the operational efficiency part of building for climate change is, can we reduce that significantly down? So what if we could achieve buildings that only need 10 or 20% of that? So we're only talking about 0.3 of a tonne per year of emissions rather than 3.3. And just to put that in another context, the book that Katie put up before about how bad bananas are, is in there they talk about a 10-tonne lifestyle, so people having 10 tonnes allocated to them per year for their emissions across everything they do. So if we're emitting 3 tonnes just from our house, keeping it comfortable and warm, that's already a third of our annual emissions budget per person that we can use. So operational efficiency is really important. It's also something we can do really quite directly with our buildings and quite easily in a sense. The part of that I want to talk about, which is a really big part of it, is the thermal performance of buildings. So there's a whole lot of different aspects of buildings that impact on how many operational emissions there are. One of the big ones, which makes up about a third of that, is the thermal performance of the building. And this means how the building is designed and built so that it can stay comfortable all year round without using, or how much energy it needs to use to stay comfortable all year round. So this is about how much insulation it is, but also how much insulation is used in it but also how well it's put together and the shape and the form of the building. And people quite often talk about the annual heating demand, so the kilowatt hours per square metre of that building to maintain it as comfortable and healthy inside. And if you design and build a very complex building, so perhaps a cruciform plan, that can have twice as much surface area as a building which is more simple in form, so a rectangular one, which means that you need twice as much insulation just in order to keep the same level of thermal performance for that building. And then the other aspect of thermal performance, which is really important, is that it relates directly to the health and well-being and how we experience our buildings. And I think that one of the things we've got to really keep in mind all the way through this process is that as we make changes to how we design and use buildings, is that as was touched on by one of the very early speakers, is that buildings are for people. So people need to be at the centre of what we're doing when it comes to climate change action and the way we design and build buildings also. And it's quite possible to think about low operational emissions for buildings as being about put another jumper on and kind of like try and keep warm in a very poor indoor environment, which I think most of us in New Zealand have grown up with that kind of experience. And I grew up in Canterbury, just outside Christchurch, so I'm quite familiar with very cold winters and wearing more layers of clothes and seeing my breath in the morning. But that's not what we want to achieve with this operational efficiency being brought in as part of building for climate change. We want to see that as buildings get more energy efficient, we want to see indoor environmental qualities, so how warm and dry and well ventilated they are, is also improving at the same time, not being compromised. And these things have a relationship between them. So buildings operate as a kind of system. So if you change one part of the system, you have an impact on another part of them, which is why I've got this triangle up on screen to try and give a bit of a clear kind of insight into how these things can relate to each other. So the first thing we can say is if we want to just simply improve indoor environmental quality, we should probably just heat our buildings and ventilate our buildings a whole lot better than what we do typically at the moment. And if we just do that, then we inevitably use more energy because we have to just start using bigger heaters and more often. And if we go the other way and we say, actually, we just want to reduce energy use, we want to reduce operational emissions, and we don't really want to think about the other things, then you can have a negative impact on indoor environmental quality. So even if you put another jumper on, if your house is cold, it's not going to be very good for your health or your well-being. If, on the other hand, we take a different approach and we say, actually, we want to improve the thermal performance of our buildings and we want to relate that to how warm and dry and well-ventilated and healthy our buildings are, then doing those two things in conjunction with each other inherently pulls down the amount of energy we need to use in our buildings. So this is one of the reasons why thermal performance is really critical in terms of getting the balance right between lowering operational emissions and improving the indoor environmental quality of our buildings. And the way the building code works in New Zealand at the moment, these things are covered, but they're kind of covered in different aspects and they don't relate very strongly to each other. So part of the building for climate change work is looking at how we do bring these things together so that we have a building code that works on outputs or outcomes for people and for the environment, and not just about what the inputs that you put into designing a building are. I just wanted to touch on a couple of things which Katie already picked up on some of these things. So other things the government is doing around this kind of area is that there's a carbon neutral government program underway, which is that all ministries and agencies that are part of the government need to reach carbon neutral in their operations by 2025. I believe this also impacts on local governments. So this is reducing operational emissions, reducing embodied carbon emissions also, and then at the point where they get to the kind of reductions they can sensibly get to, then offsetting the remaining of those emissions also. We're also looking at energy performance certificates. These have been brought up quite a number of times, which is kind of a way of rating a building to say how well it performs in terms of the energy use needed to keep it at a good temperature and a healthy, comfortable interior. All the different parts of government are, of course, responding to the Climate Change Commission's final report, and the different aspects are in that. And then this year, there's a lot of work being done on the emissions reduction plan, which we expect to be published later on this year. So that's a very brief overview on the operational efficiency, and I'll pass on to the next speaker.
Kia ora, my name's Paul Finch. I'm a project manager. I work mainly in residential and light commercial space. My background was as a building engineer. I'm also a certified passive house tradesperson. I tend to annoy people, and I don't much like speaking in public, so I've done this for some time. What I'm going to talk about tonight is retrofitting. Oh, well done, blanked out straight away, there we are. What is it, why does it matter, and how we do it? And we'll see if we can get some of that done tonight. There we are. So in 2050, 29 years from now, that's about my age. Right. I understand from some figures that Katie's team gave me, I don't know if they actually called the modelling team, but we call them the modelling team. Approximately 70% of the residential building stock in New Zealand will be standing, or will be the buildings that are standing today. New Zealand statistics indicate there are about 1.8 million dwellings currently standing. Now we're going to have growth and clearance, but for the sake of this presentation, let's just say that the same amount will be around in 2050. So in 2050, about 1.25 million dwellings are going to be from 2020 or earlier. And this is going to be a similar position to other developed countries. So it's critical that in terms of reducing energy use and our greenhouse gas emission reductions, that deep retrofits are going to need to be carried out on existing stock. Right, you can quote me on that, because I said it, okay? That's my quote. Everyone now needs to be an activist right now, not tomorrow, not in 5 years' time, right now. Renovate, refurbish, rehabilitate. It's likely that if we shift our focus almost completely to the rejuvenation of existing buildings and have the reduction of energy use at the core of that focus, every project carried out will be a retrofit project. And they have to be, because we don't have any other choice. If we think about retrofitting just in the residential sector, we can just consider things like swapping out single to triple glazing, putting insulation in walls, roofs, anywhere you can fit it, and perhaps whipping out the old open fire to a wood fibre pellet equivalent. In the commercial sector, wrap up buildings and external insulation, put on new veneers, finish off with new glazed balconies. This project I co-managed back in 1998 in Norway. 3 tower blocks, 10 stories, 200 plus apartments. It was award-winning, but they didn't tell me at the time until I left the country. I found out 2 years ago. Conventionally, such refurbishment work is focused on a number of single-step measures which overall improve the performance of a building, either deliberately or unintentionally. But there's generally little thought in promoting the improved performance, how it might be demonstrated or how it will benefit stakeholders, either immediately after the works or during the remaining life of the building. And the benefits of retrofit are unlikely to have been determined at the design stage. And the influential assessment criteria upon which the project has progressed is generally cost versus asset value growth. This is just sort of standard retrofitting, just adding something that wasn't there before. The long-term benefits to occupiers or owners will initially be largely only perceived and found on subjective reasoning rather than as the consideration of demonstrable outputs from the setting of measurable targets. So although this project on the screen wasn't award-winning because the residents after 40 years could finally push their sofas back against the external walls without feeling cold, or they could sit out on their balcony comfortably in cold months without freezing, it won because the work was of high quality to budget and at the time it looked nice. So typical retrofits might result in a 10 to 25% reduction in energy use, but that's not enough. I've got no idea how this performs now, but I do know it still looks nice. In addition to the definition of retrofit, I've added by taking the whole building approach to achieve an improvement in energy efficiency towards near net zero energy demand. And now we're wanting to start focusing on performance and reducing energy use. This picture has been taken from Archetype's website. Thank you, Tim, and the team down there, Dunedin. They looked at retrofitting an apartment flat, I guess, or an apartment in a block. And here the people have started going a bit more hardcore, stripping out plaster from external masonry walls, putting in new insulated timber walls inside the envelope, airtightness membrane, up with the floor, more insulation, more membranes, and so on and so forth. Whopped in some through-the-wall MVHR to reduce moisture build-up and to warm the incoming fresh air. And further along the residential line, Kāinga Ora have already retrofitted 200 homes in the Hutt Valley, and they plan to retrofit 1,500 more in the next 2 years, and that's part of one of their kick-ass performance-focused retrofit projects nationwide. Deep retrofit in the commercial sector. This is about 10 years old now. It's Aorangi House in Wellington. It was a Beaker project, 2009. And they basically added the things that were on the project before in Oslo, but gone infinitely further. Installed external insulation and new veneer, high-performance glazing, solar shading, temperature and air quality sensors, exhaust fan to aid ventilation, variable refrigerant flow comfort cooling design, and worked on the elimination of thermal ridges. So the whole performance of the entire building is considered, in this case, the performance analysed for optimisation during the retrofit. If you haven't checked out Professor Johan Rockström, go and check it out. The final stage really was just looking at passive house style retrofitting at Enofit. And one example here was Piha House. They're looking to certify it this year. It's by Sang Architects, Daryl Sang and his team up in Auckland, and comes with the need to expect surprises and having to pay attention to a lot of details. And I'll just leave you on that note.
Kia ora koutou. My name is Shay, and I'm the head of strategic partnerships at Tether Limited. Prior to Tether, I led the development of the Environmental Upgrade Finance Program in Australia. Tether provides hardware for measuring building performance, and our devices are very easily installed. It can be done in 30 seconds. They run on batteries and do not rely on Wi-Fi connections to transmit data. So today I'm here to talk to you about PACT, which is Property Assessed Climate Transformation. PACT is a loan. It is secured by a voluntary targeted rate on the property. It can be used by homeowners as well as businesses. The term of the loan can be up to 20 years, and the interest is fixed for the duration of the loan. The loans range from a few $1,000s to millions of dollars, and the funding is provided by the private sector. It can support building owners and tenants too. PACT overcomes financial barriers that typically discourage investment in retrofits of existing buildings. The long-term tenure of the loan makes the loan repayments easy, and therefore it becomes a cash flow tool for the building owners. In particular, it could be used for healthy home upgrades, green retrofits or deep retrofits, as well as change of use for commercial buildings. Further to that, it can also be used for natural disaster preparedness, such as floods and hurricanes, bushfires, and earthquake strengthening. And last but not least, it can also be used for heritage building maintenance and compliance. Similar finance mechanisms are also under consideration in Europe, UK, Canada, and South Africa too. It is enabled by a tripartite agreement between a building owner, their local government, and a lender. Voluntary targeted rate programs are already operating through Canterbury programs and building retrofit programs in Auckland City. PACT is very much aligned to these programs and can also be used for non-residential buildings. It also allows for a wider range of improvements so long as they deliver a healthier space and a more efficient building, and the funding is not limited to council budgets. I'd like to run you through a series of examples of projects that have been funded by similar finance mechanisms in Australia and in the US. First, we have a commercial building refurbishment. This building was built in 1936. It's in Melbourne CBD. The building had aged and had poor neighbours rating. The building owners used bank loans and environmental upgrade finance, which is what PACT is. And they were able to do deep retrofits and lift the neighbours rating to 3.5 stars, which enabled them to source a long-term tenant. We work on a 15-year contract. The second one is for Eco Laundries. It's a small business. The building owners decided they wanted to upgrade all their washing machines and dryers for more efficient Tesla models. That upgrade is helping them save about $17,500 a year. Across from that, we've got Four Pillars, which is a well-known gin. They're exporting across the world. They decided to install a 67 kilowatt solar array on the roof to operate more sustainably. They've also got visions for a $6 million upgrade for the site to become a very sustainable gin hub. One of my favorites is a waste minimization project, which was undertaken by Booth Transport. So Booth is a very old transportation company, family owned in Australia. On this particular site, they store milk because they transport milk across Australia and they store it in big silos. But once a day, they have to wash all the insides of the trucks in the silos, and all that water contains a lot of protein. So what they did is they installed 4 swimming-sized pool worm farms at the cost of $4 million. And those worm farms treat 120,000 kilolitres of water, and that gets put back into the irrigation system each year. Prior to this, that water had to be trucked down to Melbourne and for treatment over there. And last one I want to talk about is called Residential Solar Program through PACE. So this is where this type of funding originated in the US 10 years ago. To date, for residential projects, they have transacted for over $7.3 billion, and that is across 300,000 homes in the US. Commercial PACE started a few years later, and to date, they have transacted over $2 billion worth of building retrofit projects. And the biggest deal was signed earlier this month for an $89 million commercial building retrofit on Wall Street. So from this, you can see that, the usage is from very large businesses to small businesses, as well as homeowners too. So in the last 6 months, we have been undertaking a series of stakeholder engagement activities. We've written letters to the Minister for Local Government, as well as Minister for Housing. The rationale for that is that under the current Local Government Rating Act, councils can put VTRs on council-funded projects, whereas for PACT, we're looking at the private sector to provide investment into these projects, and that would require some amendments to the Local Government Act. We've also sent a briefing paper to the Greens Party, the National Party, and the ACT Party as well, and I've been advised that it's been forwarded to the Minister for Building and Construction as well. How can you help? I'd encourage you all to talk about this pact to your peers, to your local governments, to your banks, and any projects. For consultants in the room, if you're working on projects, you can identify, projects that could be suitable for this form of finance. And please send me an email or give me a call. I'd be happy to talk more about it. The briefing paper that we sent to the government will also be available to anyone who's interested after this presentation tonight. And also, if anyone is interested in downloading those full case studies, I'll be more than happy to share the link from where they're available. Thank you very much for your time.
Tēnā koutou katoa, ko Fiona Toku Ingoa. I'm an architect from Warranamani Architects, and I also lead sustainability. And tonight I'm going to talk to you a bit about the work we've been doing and the context in which it sits. So in 2019, we witnessed and were part of global declarations of a climate and biodiversity emergency. Warranamani Architects made this climate commitment. We cannot achieve it alone. There are 3 parts to the goal for design. Net zero, because we want to encourage on-site generation and certification. 50% more energy efficient, because we want to get to net zero through building efficiency first. And 40% less embodied carbon, because research showed this was achievable without going to a full timber structure, which encourages all project typologies, products, and material suppliers to come with us on this journey. I hope that our best work will far exceed this commitment. Tonight I'm going to share with you a few insights from our journey so far to do with measuring soft skills and driving industry change needed to meet these goals. We're rapidly moving from a design based on intuition and experience to data and insight-led design optimization. We need to be able to measure our emissions from our brief to our documentation. We've never had to do this before, and the tools to do it are slowly developing. To help us determine what good or even normal looks like, last year we partnered with a PhD candidate, Emily Newmarch. Emily analysed our design for Mason Bros on Auckland's waterfront. Completed in 2016, this building achieved a 6-star Green Star built rating for office, which is the highest rating, with a 5.5-star neighbours energy rating, which is out of 6. So achieved really highly in terms of rating systems. Our engineer calculated that over its lifetime, this building saves approximately 50% of greenhouse gas emissions, which sounds fantastic. By the current tools, this is deemed world excellence and is really hard to actually beat. Emily's analysis found that this building had a 40 to 60% split on operational compared to embodied carbon, placing a greater importance on embodied carbon than a typical building due to its energy efficiency. Today, we understand to stop irreversible climate change in the next 8 to 10 years, reducing the total embodied carbon emissions, especially up front, is critical. When Mason Bros is assessed through this lens, it measures about double our goal, which is roughly international best practice per square metre. Which sounds bad, but it's not actually bad because it depends on the typology, and an office building might be 40 stories and this is 3. So it gets really complicated quickly. But the point is that when this building was designed, embodied carbon was not a priority, although it was assessed as part of the Green Star assessment. But priorities need to look different today. If this building were briefed today, this is what I would want you to ask. We need to have a clear goal and strategy, and we need to shake our assumptions. So let's look at a current project. On the right-hand side, I'm going to talk about that project. This is an office design where our brief was to see if we could make a timber structure feasible for a B-grade office building in Ototahi. We spoke to a contractor early to minimise the risk. They suggested, rather condescendingly, we should make the floors concrete for many logical reasons. The client was forced to defend the design team and explain what our brief was and why a low-carbon build was important to their organisation. We brought in a more progressive contractor for some insights, and the design team came up with a low-carbon, rational, and we think beautiful proposal. And we used the Naylor Love tool to demonstrate carbon sequestered in the structure. But in order to be funded by banks, the project needs a business case. The concept cost estimate for the business case is provided by a QS, whose job it is to put a value against the known as well as the unknown. The perceived unknown risk of timber construction in the market right now blew the business case out of the water in one foul swoop. If it weren't for an absolutely determined client, this project could have fallen over at this point, and many do. Despite the architects, engineers, contractors and client all going above and beyond, it is no guarantee of success yet. And this is because we're still operating within an ecosystem that defines success by cost, time and quality. We need to shift the whole construction ecosystem to adjust for a new value, carbon. This in itself isn't a technical challenge, rather an adaptive challenge. An adaptive challenge is achieved by overhauling people's priorities, beliefs and behaviours. It calls for productive conflict and tolerating loss as the whole system learns through experimentation and innovation. It won't be enough if we have legislation but don't provide education, financial incentives or address existing barriers. If we're not careful, it might even make it harder or more expensive to build houses. To accelerate system change, one of the most powerful things we can do is to fearlessly ask questions and work together. In summary, we need to design with more insight, we need to ask questions, we need to connect more, and tonight is a perfect example of that, and I'm thrilled to see you all here tonight. So come have a chat later if you'd like to know more. Thanks.
O kia ora mai tātou. Me mihi nunui ki te mana whenua. He mihi nunui ki ngā kai whakahaere o tēnei hui. E rere atu nei ngā mihi kia koutou. No nā te whakau e ahau, he ahorangi tūhono ki huri te ao, ki te wānanga aronui o Tamaki Makaurau. Ko Amanda Yates ahau. Kia ora mai tātou. Thanks Jessica and Michelle for inviting me to contribute to this event. It's a pleasure to be here with you. I'm an urban wellbeing researcher at at AUT's Architecture and Future Environment School, and leader of a National Science Challenge Building Better Homes, Towns and Cities Urban Wellbeing Program. We'll be talking briefly about this urban wellbeing research that focuses on developing transformative tools that aid holistic or socio-cultural and ecological wellbeing. Particularly, I'll talk about how we're working with AUT's new architecture program to co-develop tools to help architecture students learn to design for the particular challenges and opportunities that we're facing now. So a few quick snapshots to set the context. We're already well into a climate change process, with average global temperatures now up by 1 degree from pre-industrial levels. This elevation in temperature is very significant. Recent research has raised the possibility that even a 1.5 degree elevation in temperature may start to initiate tipping points that further fuel change. We're also now up to around 416 parts per million in atmospheric carbon dioxide, which drives climate and ocean heating and sea level rise. And climate change isn't the only challenge, obviously. We're also now in a 6th mass extinction event with wide-ranging biodiversity collapse. Biodiversity is the life and the life support system of the planet, and so this is just as much of an existential threat as climate change and global heating. Housing crises, obesity epidemics, which are linked to obesogenic built environments, and likely the current pandemic are all linked with our current land use and building infrastructure systems and choices. The scale of these crises are global and they're interlinked in complex ways, but the opportunity here is to emphasise holistic wellbeing or modi ora and actively design and build for socio-cultural ecological wellbeing. This is an opportunity that we can particularly engage with at an urban level and in our neighbourhoods. So what is effective? In our urban wellbeing research, we're identifying a wide range of socio-cultural and ecological wellbeing strategies, and we're exploring how to land these on the ground in urban neighbourhoods. We need tools to help us understand and visualise different wellbeing strategies and how these can interrelate and create synergies. We're developing 2 visual tools, an urban data display and a holistic wellbeing compass that keeps us oriented towards wellbeing. The urban wellbeing data display takes city-level data on wellbeing and visualises it. The display is split into key domains: built environment, transport and ecological infrastructures, circular economy and connected communities. And the visualisation plots key indices against a state of modi ora or wellbeing or modi mate, ill health. Emphasis here is on transformative approaches: renewable zero carbon energy, ecologically regenerative land use, circular bioeconomy principles, connected communities, all in order to assess and further accelerate urban regeneration. We're also developing a holistic wellbeing compass that visualises the city as a complex whole. Again, we depict key urban wellbeing approaches or actions and domains: built environment, transport and ecological infrastructures, circular economy and connected communities. With Huri Te Ao, the Future Environments Architecture School, we've just started a process of co-developing a compass to help teach architecture from a perspective of holistic wellbeing. We're emphasising an approach which always locates architecture within its neighbourhood and ecosystem. The aim is to help students to understand how to design zero-carbon, living, regenerative systems by providing key strategies or directions. For example, in the Kainga Order Built Environments domain, the ochre-coloured pie section, we highlight the importance of local renewable energy generation and storage as part of a building energy ecosystem. This overlaps with the Kore Ora Zero Carbon Active Transport Strategy, the khaki coloured pie, which emphasises active and public transport along with zero emissions vehicles. The green Whenua Ora Ecological Infrastructure section emphasises the importance of urban ecological regeneration to store carbon and enhance biodiversity in a more resilient life support system, and also to improve the wellbeing of people via the biophilia effect. Research shows that people's wellbeing is measurably improved by proximity to green spaces, and that disadvantaged children's resilience is particularly improved by access to nature. The compass brings together local and global wellbeing approaches so that students always consider how their local choices can have global effects. Global wellbeing boundaries, the outermost circles, reference Johan Rockström's planetary boundaries idea, which emphasises the need to work within existing planetary cycles and capacities. Our local, urban and architectural actions in the centre need to occur within the circling planetary boundaries, within the carbon cycle, within ecological limits, for example. The compass emphasises the need for a just energy transition to renewable energy, a land use transition which allows for ecological regeneration, and a materials transition to a circular bioeconomy. So to finish, this is a challenging time for the built environment industry and for cities, but it's also a time of great opportunity. Because of the complexities and interconnection of the challenges, we need to take a multi-pronged and holistic approach. And we need tools to understand and visualise wellbeing opportunities in urban interrelationships. This compass is one tool we're creating. We're about to begin using it with AUT's Architecture School. We hope that this approach will assist architects of the near future to design ecologically regenerative, carbon negative, living buildings and cities. Kia ora mai tātou, thank you.
Kia ora, Amanda, thank you very much. And thank you to all our speakers on Zoom and in the room. Thank you all so much for being here. Now, the speakers who are here in person have agreed to stay around for a few minutes afterwards. If you have any burning questions, please just go up and grab them and ask. Part of the idea of coming in person tonight is so that local people get together with other local people. So in that vein too, I'd like to especially thank our Expo partners. Thank you all for being here early and setting up. And if you didn't manage to connect with people who you want to, go over, maybe grab a card, say hello. And I'd like to also thank our supporters and sponsors. And we have a snazzy slide for that. And thanks lastly, but most importantly to you all. Thank you so much for coming. We're absolutely delighted that you made it. We seem to have a positive genius for choosing the worst weather to schedule our events. We've already had to cancel one in the series. Just briefly, I would like to invite you now to think about the change that has been discussed. Perhaps you're an industry professional. Maybe you own a building. Maybe you're a landlord. Maybe you're all three. Or maybe you're a citizen. Well, all of us are citizens. And change at the pace and scale we need will take us being engaged in local democracy, not just at elections, but between elections, working together and recognising how interconnected we all are. So what would enable you to be part of that transformation? Well, we hope you'll keep in touch with us. We're on social media in all the usual places, and we have a newsletter that does come out from time to time, and we will be sending out a special issue after this to follow up with some links that I hope you'll find interesting. Next, Christchurch Conservation towards 2030, sorry. Christchurch Conversation towards 2030, I think I made that up. Anyway, I'm regretting it. Our next one is on Sunday, the 8th of August. So Sunday, the 8th of August, and we will be asking, can Christchurch be a zero waste city? We'd like to see you there. Meanwhile, go well. Ka kite anō.